All right, today we're cracking open a real-life cosmic case file. It's a genuine scientific mystery about a high-speed visitor from way beyond our solar system that had astronomers all over the world asking one very big question. So, let's follow the clues. So picture this, the summer of 2025. Something comes streaking into our cosmic neighborhood, moving fast. And from the second we spotted it, the debate was on. Were we looking at just another wandering comet, or was this something else entirely? And here it is. Meet our mysterious visitor, 3I/Atlas. It was discovered on July 1st, 2025, and get this, it was only the third interstellar object humanity had ever detected. This incredible image from Hubble confirmed what scientists were already suspecting. See that fuzzy glow around it? That's a coma of dust and gas. It wasn't just a dead rock, it was active. And that one detail, well, it turned out to be the master key to unlocking this whole mystery. Okay, so every detective starts with the initial report, right? And the case file for 3I/Atlas was, well, pretty wild from page one. This wasn't your average tourist just passing through. It was a record breaker from the moment it showed up. The first thing that set off all the alarm bells was its sheer speed. I mean, it was moving unbelievably fast. 3I/Atlas had what's called a hyperbolic excess velocity of 58 kilometers per second. Now, in simple terms, that's the speed it would still be traveling at even after it completely escaped our sun's gravity. We're talking over 130,000 miles per hour. This thing was on a one-way ticket, and it was not stopping. So, the way astronomers can be sure an object is from interstellar space is by using a number called orbital eccentricity. A perfect circle is 0, and an orbit like Earth's is really close to 0. But as soon as that number goes above 1, it means the object is no longer in a closed loop. Its path is a hyperbola, a one-way trip out of the solar system. It's not coming back. So what was the eccentricity for 3I/Atlas? An absolutely staggering 6.14. That number is so extreme, its path through our solar system was less of a gentle curve and more like a straight line. It barely even acknowledged our sun's massive gravity. It was like our entire solar system was just a tiny speed bump on its journey. And just to put that number into perspective, let's look at the only two other interstellar visitors we'd ever seen before this. Oumuamua came in at 1.2, then 2I Borisov was at 3.3. But 3I/Atlas at over 6, it wasn't just an outlier, its trajectory was in a completely different class. So with data this bizarre, you can imagine the scientific community was scrambling for an explanation. It was time to bring in the usual suspects. Was this thing a comet, an asteroid, or could it be something else? And this is where things got really interesting. One theory that grabbed all the headlines came from a team including Avi Loeb. They argued that its trajectory was just too unlikely to be natural. They raised the provocative idea, as a thought experiment, that maybe, just maybe, we were looking at an extraterrestrial craft. But the mainstream scientific community pushed back, and pushed back hard. Astrophysicist Darryl Seligman, who led one of the first big studies on it, said, "Hold on, we're already seeing all the classic signs of a comet." So the battle of ideas was officially on, and it was going to take our most powerful tools to settle it. Speculation is one thing, but science, well, science demands evidence. To finally settle the debate, humanity turned its most powerful eyes toward this visitor. The Hubble and the James Webb Space Telescopes were about to become our definitive cosmic detectives. And oh man, did the James Webb deliver. It gave us the smoking gun. Its powerful instruments were able to detect the actual cocktail of gases boiling off the object's surface, a chemical fingerprint that basically screamed comet. We saw carbon dioxide, water, carbon monoxide, even tiny traces of cyanide and atomic nickel. So that was it. Case closed, right? Well, not quite. Because this is where the story gets even better. While we now knew what it was, the data from Webb revealed something even more fascinating. Solving that first mystery only opened the door to a much deeper, and honestly, a much more exciting one. Okay, check this out. The puzzle got so much deeper when scientists looked at the ratio of those gases. It turns out 3I/Atlas was spitting out about 8 times more carbon dioxide than water. Now, for the comets in our solar system, that is completely backwards. This was one of the most CO2-rich comets we've ever seen. It wasn't just an interstellar comet, it was a chemically alien comet. So that weird chemical signature was one clue. The other was its trajectory. By tracing its path backward through space, astronomers pinpointed its origin, the Milky Way's thick disk, a super ancient population of stars. And that led to an absolutely stunning conclusion. 3I Atlas could be up to 14 billion years old, possibly older than our entire solar system. Just let that sink in for a second. This object probably formed around another star near the very dawn of our galaxy. It got ejected and then spent billions of years just wandering the cold, dark void between the stars before, by pure chance, its path happened to cross ours, letting us see it for just a brief moment in time. So after all that, what's the final verdict in the case of 3I/Atlas? Yeah, the investigation started with a high-speed interloper and some wild speculation. But the evidence tells a far more profound story. It's not a spaceship. It's a time capsule, an incredibly ancient, chemically bizarre messenger, carrying the actual building blocks of another, long-gone solar system. It's a pristine relic from the very childhood of the Milky Way. And that is why this visitor matters so much. It's not just a rock, it's a pristine sample of another solar system's raw ingredients, delivered right to our cosmic doorstep. It proves that the chemistry for building planets across the galaxy can be radically different from our own. We were given a direct window into the distant past, and we got to analyze what is very likely the oldest comet humanity has ever seen. The story of 3I/A proves that the vast, dark space between the stars isn't empty. It's filled with these incredible messengers carrying tales from across the galaxy. It just makes you wonder, with all the new telescopes we have coming online, what other ancient stories are out there just waiting in the dark for us to find them?